All right, today we're going to talk about a statistical tool that is, believe it or not, both super simple and incredibly powerful. It's called Simple Linear Regression. Now, I know that sounds a little technical, but really it's all about one thing: using a straight line to find hidden relationships in the world all around us. So let's jump right in. So let's kick things off with a huge question. Can the number of years you spend in school actually predict how much you'll earn later in life? I mean, it feels like they should be connected, right? But by how much? Could you actually put a dollar amount on that relationship? Well, that is exactly the kind of question we're going to tackle. And the tool for that job is Simple Linear Regression. At its heart, it's a method that takes a whole bunch of scattered data points, like the education and income for tons of different people, and finds the single, best-fitting, straight line that cuts right through them to show us what's really going on. And here it is. This is the formula that makes it all happen. I know, letters and Greek symbols, it can look a little intimidating at first, but trust me on this. Every single piece of this puzzle has a really simple, really intuitive job. We're going to break it down piece by piece so it all makes perfect sense. First up, we've got the star of the show, y. This is our dependent variable. Just think of it as the answer you're looking for, right? The big mystery you're trying to solve. So in our example, y is the future income we want to predict. It's our target. So how do we predict y? Well, we use x, the independent variable. This is our clue. It's the piece of information we already have that we think is going to help us make a really good guess about y. In our case, x is simple. It's the number of years of education. Okay, now for our first Greek letter, that little b0, which we call beta 0. This is the y-intercept. It's just a fancy way of saying it's our starting point. What would our model predict for y if our clue x was 0? It's the baseline before anything else even gets factored in. And this brings us to beta 1, the slope. Honestly, this is the real engine of the whole formula. The slope tells us exactly how much our prediction y is going to change for every single 1 unit increase in x. This number is what truly captures the relationship between our two variables. And finally, we've got this little guy, epsilon, the error term. Look, the real world is messy, right? No single straight line can perfectly predict everything. This symbol just acknowledges that fact. It's the gap between our model's perfect line and what actually happens in reality. You could say it's our little dose of humility. Okay, enough with the theory. Let's see how this all clicks together with our real-world example, education and income. This is where those abstract ideas suddenly get very, very real. So let's just map it out to be super clear. The variable we want to predict, our y, is income. And the clue we're using to do that, or x, is years of education. We're just trying to figure out how x can tell us something meaningful about y. Simple as that. Now, imagine we've crunched all the numbers, we've run our data through the regression model, and it spits out an equation that looks something like this. All of a sudden, those abstract symbols become actual dollar amounts. This is our prediction machine. But the big question is, what does it actually tell us? Let's start with that first number, $10,000. That's our intercept, our beta 0. So what does it mean? It means that according to our model, with 0 years of education, the predicted starting income is $10,000. It's the baseline on our graph. And here's the engine, $5,000. This is our slope, the beta 1 value, and it's the real insight here. It tells us that for every single additional year of education, our model predicts that a person's income will go up by $5,000. That is the power of the slope. It puts a number on the impact. So let's zoom out for a second. We've gone through the terms, we've walked through an example. Now let's talk about the big picture, the real power of this simple line and, what it actually means for you. So, to boil it all down, Simple Linear Regression takes messy, scattered data and finds the one straight line that makes the most sense of it all. It lets us use one thing we know, our x, to predict something we don't know, our y. But most importantly, it doesn't just say, hey, these two things are related. It shows us how they're related, with the slope telling us the exact rate of change. It literally turns a hunch into a number. And that kind of leaves us with one final thought. We've seen how a simple line can connect years in a classroom to dollars in a bank account. So the real question for you is, what other dots could you connect in your world? Maybe it's the link between a city's temperature and ice cream sales, or a website's loading speed and how many customers stick around. The world is just full of these hidden relationships, and now you have a really powerful tool to start drawing the lines between them.